All right, so this is day 3. What you recall from what we did before is we looked at fundamentals of design strategy with dynamic patterning, and then we really went into data trees and how data is structured. So at the end of yesterday, we really kind of dug down into some more process-based understanding, like how to construct, deconstruct, and reconstruct information and isolate that information for the reconstruction process. So today, very, very significantly, all of that was done in just the XY plane. So today what we're going to start to do is explore the three-dimensional mapping environment a little more, okay? But in order to do that, we have to start on the two-dimensional plane again so that you can start to get your bearings on what's what. So what I'm going to do here is, first get Grasshopper running. But what I'm going to do here is really just kind of start off with some surface-based understanding of three-dimensional coordinates, mapped coordinates on a plane. And really that comes in the form of a U and V coordinate. I'll explain what that means in a moment. But let's do this. I'm going to start by just creating a couple of shapes here. So I'm going to just do a flat rectangle like this. And then I'm going to take a surface from 3 or 4 corner points, and I'm going to do something that's a little bit differently shaped. Okay, so something like that. So I'd like you to do the same, and you can make this, you could leave it as a rectangle, or you can make it a surface by typing in Planar Surface if you want. So just make sure that you have one surface or rectangle like this, and one surface or rectangle shaped like this. Okay, and for those of you who don't know Rhino that well, I can swing by real fast and try and get it put in there for you. All right, so after you have the surfaces here, what we're going to do is reference them both in. So if you kept, actually I'm going to delete this and go with the rectangle option and explain sort of how you can do it both ways. If you created a surface, it's as easy as going up to the params menu under geometry and pulling in the surface component. And it comes through just as an empty housing for data, like I mentioned before. You right click it and go to set one surface, and it'll reference that surface for us. And similarly, even with the rectangle, I don't know if you can reference it directly to a surface. I'm going to try it just to... No. Okay, so what you have to do, I don't know why I tried that. It was silly, but anyway, what you have to do is under params, go to geometry and pull in the curve param. And then you're going to right click that and set one curve, and you're going to select that profile. And then connect that profile to the surface. So right off the bat, I have a little bit of a preface for what's going to happen later on. Take a look at these two surfaces. What do you notice that's different about the two? The less you guys speak, the more questions I'm going to ask. What's different about those two surfaces?
The first one hasn't been baked, right?
Well, yeah, but this one hasn't been baked either, because really all we did is we took this surface and we just kind of copied it into Grasshopper in a way. A good thought, but yeah, no, that's not it. Think about on the Grasshopper end, right? The Grasshopper definition is generating things in a red color, right? So this one is very red, like it's almost like a pink. But this one is like a dark red, like a maroon. So if you're observant enough, you can notice some of these subtle differences because it actually means something. And what it means is that the surface of the square on the left is facing us. The positive direction of that surface is facing us. and then the positive surface of the one on the right is facing away. Okay, so when we move forward into understanding, the z-axis, you'll start to explore that a little more. So we have the two surfaces now, and so what I have to preface right now in 2 dimensions is the idea of a u and a v coordinate. A u and a v coordinate is similar to the x and the y coordinates as if it was an x and y plane, but it's as if you've bent the plane into a 3rd dimension. Does that make any sense to you? So basically, if I subdivide my flat rectilinear panel, that one I'm going to get straight lines that goes all the way across it. But if I subdivide the one that's sort of oblong and oblique, that one's going to have lines that tend to converge. And so those are going to be u and v axes instead of x and y. So how do we visualize that? How do we actually subdivide it and see what it looks like when we break down these 2 different shapes? It's actually done using domains. If you recall from yesterday, I introduced the idea of a domain. And the way I introduced it was with numerical boundaries. So instead of numerical boundaries, what we can do is use a pre-existing geometrical boundary, and then we can do operations within it. You guys understanding that conceptually, at least? So I mentioned that a domain can be anything. In that case, it was numbers. In this case, it's going to be a surface. So let's kind of just jump into it. Under the Math tab, and then under the Domain panel, the one that I want you to focus on right now is Divide Domain Squared. Now, Divide Domain Squared has 3 inputs and it produces 1 output. It's important to understand what these are. This is a very, very important node for us. We're going to use it a lot. So Divide Domain Squared, all it says is that it divides a 2-dimensional domain into equal segments. And 2-dimensional is kind of misleading, because 2-dimensional really just kind of means that a 2-dimensional plane in this case can be warped. So anyway, it's going to ask for the domain that it's going to subdivide, and so that would essentially be the surface. Let me pull these down. And then we're also going to need, under the u count and the v count. So the u and v coordinates are going to replace my x and my y. And so just like the subdivisions that we did for the grid, right, counting how many we wanted on the grid, we can do the same thing for the u and v. So keeping the number simple, I'm going to go from 0 to 10. And you won't see anything yet. That's because all this has really done is set up the data points. It's basically setting up control points for the operation within that boundary. Okay, so you won't see it yet. So the other component to this, and this is kind of a big triangle here between a surface input, the subdivide domain, and then the operation at the end, is actually under surface. Let me get this tagged for you. It's under surface and utility. Yes?
Sorry, I'm having trouble opening Grasshopper. It's not showing up. I closed the program several times now.
Okay. Let me just finish this thought, and then I'll come help you out. So under the surface tab, and then the utility panel, the tool that you're looking for is called isotrim. And isotrim is something that is going to confuse you the first time around, most specifically because when I click on the isotrim tool and I put it in the workspace, it says subsurf, not isotrim. Oh, you got it? Okay. Were you opening like the 32-bit version or the 64-bit?
I wasn't opening that one. I was opening the 5.0.
Okay.
I opened the 64.
So the subdivide surface is isotrim in a way. So basically what this needs, if you look at what it's requesting, all it's asking for is a surface and then a domain. And that domain is basically the data points that you're going to use to subdivide that surface. So the S, and this is what I'm talking about with your inputs and output letters and making sure that you're not just connecting them to like letters, because the S is a segment, it's a domain, and it's going to be plugged into the D, not the S. Okay, so pay attention to what types of inputs you're putting it into. So the S gets plugged into the D, and then the surface gets plugged into S. And here you'll see that this panel is being subdivided however many times. You can't really see that very well. There you go. Okay. So this panel is being subdivided however many times I change my slider to.
What type of surface is that?
I just did a 4-point surface like this.
No, I mean on the Grasshopper.
That's a param under the params tab. Okay, so take a look at what this is doing. You can see that these lines, these axes, are basically coming to a conversion point because it's an odds-shaped thing. But if you take exactly the same rest of your definition, so everything but the surface. And by the way, I don't think I explained this, but if you select part of the definition like that and you want to add a selection, hold Shift and select the rest. And then you can Control C to copy, Control V to paste. And then all you have to do is just replace the connections with the with the other surface, and then you'll be able to see it on both. So once I plug surface into I and then surface into S, I have that same subdivision happening on the other side. So exactly the same thing, except this one follows the XY plane, the other one does not. And it's all because of the shape of the surface itself. So what questions do you have? All right, well, I'm going to stop this video. I'm going to make sure everybody gets caught up because a few of you came in late, and then we'll get going here in just a sec.